This is the second part of the Calculus AB Practice Final A MCQs. We're given this piecewise function here, and we're trying to solve for c plus d at x equals 1 when the f function is differentiable. Remember, when a function is differentiable, it is also continuous. So our first step here is to check for continuity. And to check for continuity, you're going to set both of those piecewise functions equal to each other at x equals 1. So it's going to be c times 1 minus d is equal to 2 plus dx, but in this case x is 1 cubed. So we're left with c minus d equals to 2 plus d. And then now we're going to subtract d from both sides, and we're left with c minus 2d is equal to 2. We're done with our first step here, which is checking the continuity of the function. Now we're going to solve for differentiability. Now, to check for differentiability, you're going to have to set the derivative of those piecewise functions equal to each other. So the derivative of cx plus d set equal to the derivative of 2 plus dx cubed. The derivative of cx is just c, and the derivative of d is 0, so that doesn't really do anything. The derivative of 2 is 0, and the derivative of dx cubed is 3dx squared. But we're going to replace that x with 1, which you're left with c equals 3d. Now we're going to plug that in to this. So our third step is to plug in. And now we're going to plug in 3d into that c on the left. So it's going to be 3d minus 2d is equal to 2, which means our d is equal to 2. Now we're going to solve for c, and c equals 3d. So that's our fourth step. So now we're going to put c equals 3 times 2. And 3 times 2 is 6. So c equals 6. But the question is asking for c plus d. 6 plus 2 is equal to 8. So 8 is our answer. Your option C is the correct answer. Now it's asking, what is the slope of the line tangent to the curve y equals arcsine of x halves at the point which x equals 0? So we're trying to look for dy dx. Now remember that we have a point here and we have a slope here, meaning we can complete the entire equation by looking at the equation itself. But it's just asking for the slope. So we're just going to look for the derivative of this and evaluate it at x equals 0. So our first step is to derive. So y prime of arcsine is going to be sine inverse. Not sine inverse. It's going to be 1 over root 1 minus x squared. And now we're trying to evaluate that at x over 2. So we're going to replace that x with x halves. And then remember that we're trying to apply chain rule because this is f. Remember that the chain rule equation is f prime of g of x times g prime of x. So this was our f, and this is our g. But we already found the derivative of f, and we left g alone. Now we need to find g prime, which is 1/2. So now we're going to evaluate this at 0. So it's going to be it's going to look something like that. So it's going to look something like this. And now we're just going to simplify everything. 1 over root 1 is just going to be 1. And 1 times 1/2 is just 1/2. So our answer is going to be 1/2, which is option B. 27 shows a slope field. Now we need to match it with each differentiable equation. What I like to look for in slope fields is for horizontal asymptotes. But it's not really clear if we do have one or not. But let's try. So what this is basically saying, at dy dx, x times y, let's evaluate it. So let's look at each quadrant. Actually, we can't because there's 2 slopes here. We're given some sort of parabola at the right, I'm assuming. So, yeah. We're gonna have to evaluate this. Let's look at the most obvious questions, or the obvious options that we can cancel out. So basically, this slope is saying at x equals -1, there is going to be an x-intercept. Is there going to be an x-intercept? There is not, because there's an asymptote at this middle, or there's no slope, indicating that there's a 0 slope in this middle. So E is canceled out. E is not one of our answers. Now let's check A. So basically, if x equals 0, that means that there should be a horizontal asymptote, which there isn't, because all of these are decreasing functions, meaning the slopes are less than 1. So if x is 0, then y should be 0 too, which gives us a 0 slope. This is not the case, so option A is crossed out. Let's look at option B. X times y minus y. So remember, let's look at the x equals 0 part here. This line here. So if x equals 0, that means all the slopes should be 0, but we're subtracting it by y. So if we're subtracting by y here, if the y's are positive and you're subtracting by those positive numbers, so let's say that we're at 0, 1, and it's going to be xy minus y. So let's see. 0 times 1 is going to cross off, minus 1. Is the slope decreasing? Yes. And the same thing happens with 2. It's just going to be -2, which means that the slope is just going to be more narrow. That is also the case here. Let's look at the bottom of the y, below the y-axis, below the x-axis. Let's check if it's also giving us the same criteria. So our equation is x times y minus y. So we can ignore this part here, since we're at x equals 0, and we're going to look at negative y. So negative at -1 is going to give us a positive slope, which here it does give us a positive slope, and also at -2 it gives us another positive slope, but it's more narrow. So it does match the criteria of option B. Let's keep option B. Let's give it a star for now, and let's see if there's any better answers that we could find here. Let's see. xy plus y. So let's look again above the x-axis. xy plus y. Remember that we can ignore this since we're at x equals 0. We're gonna look at this pole right here, And let's see. At 0 comma 1, is it positive? Is the slope positive? No, because the slopes are decreasing. It's going here, so it's going to be negative. So we can immediately cross off that option. Let's check C or D. xy plus x. So let's swap things around. At x equals 0, xy, remember that we can cross off the x times y because we're focused on x equals 0. That way we can find our best option as quickly as possible without having to do too much algebra to check each individual slope field. So at x equals 0 comma 1, it's going to be a positive slope, or it's going to be plus x. So it's going to be 0 times 1 plus 0. So that's still, our slope here is supposed to be 0, which is not the case. So we can eliminate option D, and now B is our answer, which it does match the solution's answers, so that is correct. Now let's focus on question number 28. Let f be a differentiable function such that f of 2 is 8, f of 5 is equal to 2, f prime of 2 is equal to negative 4, and so on. And then it's saying that the function g is differentiable and the g of x is equal to the inverse of f and for all x. And what is the value of g prime of 8? So if you guys remember, sometime between when first semester ended, you were given this equation, which is g prime of y equals 1 over f prime of x. So now we're trying to evaluate at a specific point. So now the first step is to find the coordinates. So we are given a y value here, a y, and now we need to look for the corresponding x, which is this also. So which x value gives you 8? Well, that's the only thing I see here is f of 2. So that means f of 2 is equal to 8, meaning our x is 2. Now we're going to plug everything in. So it's going to be g prime of 8 is equal to 1 over f prime of 2. And f prime of 2 above is negative 4. So it's going to be 1 over negative 4, which is just negative 1/4. So our answer is going to be A. And then, that's it. This concludes part 2 of the practice final part A MCQs. I believe you are not allowed a calculator here, so you have to do everything here with your algebra. Good luck with tomorrow's final, and thank you for watching.